Hello, this is Professor C.P. Prakasham, former professor from International Institute for Population Sciences, Mumbai. I will be discussing about ANOVA, analysis of variancy with two factors. Two-way analysis of variancy. Analysis of variancy is a parametric test. It compares two independent, that is two factors, means with one continuous dependent variable mean. Two-way analysis of variance is used to determine an interaction effect between two independent variables, that is called as the two factors, on a continuous variable, that is a dependent variable. Also, it determines whether there is a main effect of each factor on the dependent variable. The population from which the samples were drawn must be normally distributed. The samples must be independent. The variance of the population must be equal. This will be tested by the Leibniz test. The groups must have the same sample size. A dependent variable that is measured in a continuous level, interval or ratio level, it should be measured. Two independent variables should be consistent of two or more categorical independent variables with two or more groups. No significant outliers should exist. To test the results of analysis of variancy, F-test is used with the null hypothesis that there is not an interaction effect between two independent variables, that is factors, on the dependent variable which is a continuous. Alternative hypothesis is that there is an interaction effect between two independent variables on the dependent variable. To summarize the results of analysis of variancy with two factors, the F tables will be used and the calculations are as follows. First is the source variation, second is the sum of squares, and third is the degree of freedom, and mean squares, and F ratio. The F ratio is calculated between rows, that is between factor A, between columns factor B, and an interaction between them, and error also residual. This is the difference between the one-way analysis of variancy and two-way analysis of variancy. Then sum of squares will be calculated and degree of freedom will be -1, row -1, column -1. Here the interaction will be the multiplication of row -1, column -1, and the total will be n-1. This is the degree of freedom. With the given degree of freedom, mean squares and average mean square is divided and the F ratio is calculated. That will be the calculated F ratio from the analysis, and that will be compared with the F ratio which is given by the standard tables. Here we will illustrate how to calculate the analysis of variancy with an example. A researcher is interested to find out the variations in fertility across wealth index and level of education. It is a hypothesis that as the wealth index or as the richness increases, there will be decline in fertility, and as the level of education increases, there is a likelihood of decline in the fertility or less fertility will be there. Collection data from a large survey, that is NFHS 5. Fertility is measured, children ever born, and the wealth index, which is 5 categories, as the poorest, poor, middle, rich, and richest, and highest level of education is given here. Therefore, the dependent variable is the children ever born is taken, and the two factors are the one is the wealth index and as well as the another one is the education, which has been given as a category. Here is the hypothesis. Null hypothesis says that no interaction effect between two independent, that is two factors, wealth index and education, on the dependent variable, which will be taken as the children ever born here. Alternative hypothesis, there is an interaction effect between independent factors on the dependent variable, that is the fertility, children ever born. This is the data set. You can see here, first variable is a continuous variable, total number of children ever born, and then it is given as it is measured. Second variable is the education, highest education, which has been coded in terms of the secondary, no education, primary, higher education, and all these things. And third factor, that is the first factor and second factor, and CEB is the variable. So the second factor is the wealth index, which has been measured in terms of the coded value, that is middle, rich, poor, poorest, and other things. You can see here these are the variables which are continuous as well as the coded variables are there. Then for analyzing the two-way analysis of variance, analyze, go to the general linear model, univariate, click. Once you click it, since the total children ever born is a dependent variable, you put it here, and then highest education is one factor, wealth index is another factor. Then model as keep it here. Contrast you can make as a contrast as it is, because it will take the first or second none, and plots are required. Education is taking the horizontal and wealth index is taking the vertical, that is x-axis, and add for the interactions and click continue. And post hoc test you can measure, and then for the education as well as the wealth you can take it and then make it a two-key test of post hoc and click. Afterwards, options. You can have options, descriptive statistics, estimates of effect size, homogeneity test. But estimates of effect size is not that much required, because the sample size, if it is very large, it is taken into consideration. Then you can say significance level, keep it as it is, 5% level, and then say OK. And then if you want to have the syntax, then you can make paste, otherwise you can make continue. You can see here the first one is the syntax, and second one is the univariate analysis, that is the between the subject factors, higher education and wealth index, and these are the sample size it is given. Then next one is the descriptive statistics in relation with the factors, that is the higher education level and wealth index. Similarly, the next one is the Lebanese test. This Lebanese test is the description which will show that a similar variancy of each group of measurement can be assumed. This is the assumption here. It is given, test the null hypothesis that the error variance of the dependent variable is equal across the groups. This we will discuss in the next one. And test of between the subjects, what is the effect of the children ever born. Education level, it is a significant, wealth effect is significant, and education where the interaction is also the highly significant level. Further, if you want, post hoc test results are given here, and homogeneity subjects is also given, and wealth index combined with the poor, what is the relation between the mean number of living children, it is given here, mean deviation. And last one, which is important, is the profile plots, which has been given here. This we will discuss one by one. This is the output, SPSS output. In this, one of the foremost important thing is the Lebanese test. This Lebanese test tells us the homogeneity of variance assumptions have been violated or not, with a hypothesis, with a null hypothesis, that the error variance of the dependent variable, that is children ever born, is equal across the groups, that is between wealth as well as the education level. The output illustrates here that the education level and wealth index are significant, reveals that there is a error variance of the dependent variable children ever born is not equal across the education level and wealth index. Because the main effect is significant, in the Lebanese test, the post hoc analysis can be carried out. Otherwise, further analysis of the analysis of variance cannot be carried out, and we have to examine the variables once again and the data set to adjust this. This allows further analysis and comparison of the marginal means for the effect of the factors on the dependent variable. Therefore, the test between subject effect further analysis has been carried out, and it shows that there is a significant interaction effect, education with wealth, on children ever born, that reveals that there is an influence of wealth does depend on education in influencing the children ever born. This significant interaction effect is further analyzed by using the mean plots. This will give the profile plots of each factor. Here on the dependent variable. Here you can see the y-axis is the estimated marginal means, and x-axis is the highest education level, and estimated marginal means of the total children ever born in relation with the wealth index. Here it shows clearly, profile plot shows that as the education level increases from no education to higher education, the mean children ever born decline with the wealth index. Further, poorest, poor and middle wealth index shows high mean children ever born with low education level. Therefore, it can be concluded that analysis of variance results reveals that the mean number of children ever born varies according to the level of education across wealth of the household. End note. This is very important. Analysis of variance is a statistical test which decomposes the total variance into variance within the groups and variance among the groups. That compared with the comparison will be done by using the F ratio test. Analysis of variance tests whether group means are equal by comparing the variance, that is the variation among the group means greater than expected by chance alone. This chance alone will be satisfied with the assumption initially one has to test Lebanese test, and if the Lebanese test is results are significant, then only analysis of variance can be carried out. Otherwise, further analysis cannot be carried out. This is the most important, and the Lebanese test is the criteria for further doing the analysis of variance. Further discussions are there on this matter.